Assalamu alaikum and hello everyone. Welcome to Mathematics with Shahab Yaqub. Now, in this particular video, we are focusing on exponential function word problems. So let's get started. Now, first of all, the basic idea. What do we mean by exponential function? Let's take, for example, an amount of $100. This is the yearly salary of a person, and it's increasing every year by a value of 10% on the previous year's amount. That means at the end of year one, the value would be 100 plus 10% of 100. So this is 100, this is 10, that comes out to be $110. Similarly, at the end of year two, it would be 110 plus 10% of 110. So this is 110 and this is how much? 11. That comes out to be 121. Similarly, at the end of year three, it would be 121 plus 10% of 121. This is 12.1. This is 121. Therefore, this becomes 133.1. That means a value of 100 became 110. And the next one, that is 121. The next one, it's 133.1. So this is like an exponential growth because the difference is not constant. The difference over here is 10. The difference over here is 11. The difference over here is 12.1. So the difference is not constant. Therefore, it's an exponential growth. And it's following a certain pattern. We also call it in pure maths further up. So this is called a geometric sequence, a geometric progression. Why? Because 110 over 100 is 1.1. And similarly, 121 over 110 is 1.1. And similarly, 133.1 over 121 is 1.1. So it's multiplying by a constant value of 1.1. So that is a bit of background knowledge. So now coming back over here, now I have reintroduced the compound interest formula. This P, that is the principal value, the initial value. It could be amount, it could be population, and so on. R is the rate. And division by 100 is already there to convert it into decimals. So the rate as a percent, and N is the time period. So just be careful with one thing. If the rate is yearly, then the time period has to be in years. Let's say if the rate is monthly, then the time period has to be in month. If this is weekly, then the time period has to be in week. And this compound interest formula we use. And last but not the least, what is A over here? A is the total value of the investment or the population at the end of that particular period. Now over here, this thing basically is just following the same rule. So compound interest and exponential growth, it's exactly the same thing. So it could be about increase. It could be about decrease. If it's about increase, we will write 1 plus r over 100 raised to power of n. If it's about decrease, this is 1 minus r over 100 raised to power of n. Don't forget to write over here p. Don't forget to write over here p. And that is the value of the investment or whatever the population is. So now this is called exponential growth. This is called exponential decay. So now we'll do some problems, both from O-Level Math 4024 and Igcse. Now let's look at the O Math syllabus that is for this year, which is 2025. And you people already have had your exam of paper one. So we are sitting at a stage where paper one is already done and you all did wonderfully well. I'm so happy for all of you. And now it's time to focus the attention on paper two. So in paper 2, you might come across a question of this. Now, what are the different areas which were mentioned in the syllabus? Let's focus on that. In the concept of numbers, that is topic 1. So topic 1, let me write over here. That is about numbers. So topic 1 is numbers, and the subtopic is 1.7. Use exponential growth and decay, depreciation, population change, knowledge of E. This is exponential, a particular thing called Euler's constant, where E has a value 2.718 and something. This knowledge is not required. That will come in A level second year in P3, not right now. Graphs of function. Over here, they were talking about drawing the graph, and again over here, draw and interpret graph representing exponential growth and decay problems. And last but not the least, that is 2.11. So by the way, this is 2.10, this is 2.11. This is related with topic number 2, that is of algebra. So the concept of numbers is spread over, the concept of exponential, it's spread over numbers, it's spread over algebra, it's related with graphs. Again over here, this thing exponential, and we were doing different graphs based upon this. We have to have the knowledge of horizontal asymptote. There is no vertical asymptote in exponential, there is horizontal asymptote, and so on. And if you want to have a good idea, so that is about this thing. Let me just enlarge it so you can have a good look. So search for this thumbnail on my playlist, and the concept is thoroughly explained over here. So this video was uploaded maybe a week before, and now I'm working on the second video, which you'll soon see. So now we are first looking at O-level math questions, and these are from the specimen paper. So let's look at the first specimen paper, which is this one. And basically, it's a paper 1 thing. So let me highlight over here, but the same concept can come in paper 2. Now the line, the difference between paper 1 and paper 2, it's very negligible. Except for the use of calculator, there is not much of a difference. Now it says the diagram shows a sketch of a graph. This is the graph. The graph crosses y-axis at point A. Find the coordinates of point A. So the first basic thing is that, let me plug in x is 0, y is equals to 3 into 2 raised to power of 0 plus 5. I think I would better write this thing as this, 3, 2 power x plus 5. That looks better to me. And then 2 power 0 is 1. So therefore, this is 3 into 1 plus 5. This comes out to be 8. So therefore, the coordinates of point A, that is the x coordinate, that is the y coordinate, that's how you label it. Now let me just correct this thing also over here. So this is y is equals to this thing. Just a 2-mark basic question. Write down the equation of the asymptote of the graph. Now, when we have the graph of the form y is equals to a raised to power of x, where a is a positive constant, or y is equals to a raised to power of negative x also, where a is still a positive constant, the horizontal asymptote, the line which the curve approaches but never touches it, that line is the x-axis, and the equation of x-axis is what? Y is equals to 0. Now, when we are shifting this graph 5 units up, so what happens? So if I have y is equals to, hold for a second, so y is equals to 3 into 2 power x, still the horizontal asymptote is the same. Doesn't make a difference. If there is a constant multiplying, doesn't make a difference. So the horizontal asymptote, it's still y is equals to 0. But if I'm writing 3 into 2 power x plus 5, horizontal asymptote is now y is equals to 5 because of this constant over here. Because of this constant, nothing changes. So y is equals to kax, y is equals to ka minus x, still the horizontal asymptote is the same. So therefore, what is the answer? The answer is y is equals to 5. And therefore, first of all, let me label it. If they would ask for the graph, so I would draw it like this. And I would draw a line something like this. And the equation of this line would be y is equals to 5. So that is the answer for this particular question. Just have a good look at it. And let's move on. Now, one other thing, some people, they ask this question, can you prove it mathematically? So let me just prove it mathematically. Hold for a second. So something like this. Let's double check. So now, if I say, let y is equals to 5, 3 into 2 power x plus 5 is equals to 5. Therefore, 3 into 2 power x is equals to 5 and 5 cancel out, and I'm left behind with a 0. 2 power x is equals to 0. Therefore, 2 raised to any power can never be 0. Therefore, y is equals to 5 is a horizontal asymptote. So how did I prove? I plugged in 5 over here. This becomes 0. Division by 3. A 0 divided by 3 is 0. So therefore, 2 raised to power of x can never be 0. A positive base raised to any power can only be positive. It cannot be 0. It cannot be negative. Keep that in mind. So that is the basic logic over here. Let's move to the next question. And I'm getting my calculator ready. So grab your calculator, keep it on your sidelines so that we can use it. So now over here, the population of a village. So let me just make it a bit thicker. So now it says the population of a village is 6,800. The population of the village increases exponentially at a rate of R% per year. At the end of 5 years, the population of the village is 8353. Calculate the value of R and sketch a graph to show how the population of the village changes with time. Now, first of all, the compound angle formula, that is the same thing for this. So A is equals to P bracket 1 plus R over 100 raised to power of N. What is the initial value? That is 6,800. What is R? Unknown. What is N? 5. What is the value of the investment? Value of the population after 5 years? 8353. So this is 8353. That is P 6,800. 1 plus R over 100 raised to power of N. So 8353 over 6,800. Put it inside a bracket. This is 1 plus R over 100 raised to power of N. And now let me plug in the value of N. So we have the value of N, which is what? 5 years. This is 5. This is 5. Therefore, 8353 over 6800 raised to power of 1/5 is 1 plus R over 100. Now, some people would be a little bit shocked at this point. So just wait and realize what knowledge of O-level maths have I applied over here. The knowledge is this thing. Let me write at the sidelines over here. That knowledge is this. If A raised to power of M equals to B, therefore A is B raised to power of 1 over M. Still, some people are shocked. Let me give you some example. The opposite of square, it's square root, the inverse function. And the opposite of cube is cube root. So square is square. Square root is half. Cube is power 3. Cube root is 1/3. Power is M. Reciprocal is 1 over M. Power was 5. Reciprocal was 1/5. That's how you get it. So now I'm using my calculator. 8353 divided by 6800 and raised to a power of 1/5, or you can write this thing in decimals. 1 divided by 5 is 0.2. And this comes out to be 1.04199. 1.04199. It's 1 plus R over 100. So therefore, let me draw a line over here. And this goes like this. And let me draw another line like this. So therefore, 1.042, that is 1 plus R over 100. 0.42, that is R over 100. Therefore, R is 1.042. I missed out the 0. Be very, very careful. 0.042 is this. Therefore, R is 4.2. And what is the accuracy level? This is 4.20. After the rounding off, let me write a 0, let me write a 0, let me write a 0. So this is 4.20%. That is the rate. The value of R is this thing. So let me not write the percentage because they have already written the percent over here. The percentage sign is already there. They're asking for the value of R, 4.20, correct to 3 significant figure. So that is a beautiful question in which the knowledge of indices was applied and you found this value. The second part, it's very simple. We know that the graph of this thing, which is exponential, that will go like this. So all I have to do is to draw this line. Let me make it thinner actually. And this goes like this. So that's how exponential growth graph is. Now let me draw a line over here. First of all, let me explain to you the basic idea that we have studied. And over here, a red marker that goes like this. Let me draw a blue one that goes like this. Now let me write it over here. So this is y is equals to a raised to power of x. This is y is equals to a raised to power of negative x. This is 1. This is, let me write a k over here. Hold for a second. So this is y is equals to, this is y is equals to ka raised to power of x. This is y is equals to ka raised to power of negative x. This is a graph of growth. This is a graph of decay. With this is not decay actually. This is just a reflection in x-axis. Hold for a second. So therefore, this is y is equals to minus ka raised to power of x, and this would be k, this would be negative k. Let me add a page so that you know exactly what to do. And I'm just looking for the grid. That's the grid right over here. And let me now draw the graph of this thing. The green one, this green one is the decay. And this purple one, it's the reflection of this decay. Okay, so now let me label it again. This is y is equals to ka minus x. This is k. And over here, this is negative k. Y is equals to minus ka minus x. So this is the graph of decay, and that's the reflection. So that's the basic idea. So therefore, over here, basically, this is like this. This is an initial value. Even let's call it, talk about it symbolically. This is the initial value, and this is a value raised to power of n. So therefore, this is like this. So y is equals to population. So therefore, A is equals to P 1.0420 raised to power of n. So over here, it's n over here. Over here, this is the population. That's how the graph is. So I have further labeled it and explain you the background knowledge also. So this is also a specimen paper question. The next one, and over here, there it is, 4.20. And that's the correct sketch. And we are focusing our attention on this one. So therefore, that was the first part. Over here, between the lines, that is the second part. So now let's look at this particular question. It says an insect population. It could be about the population of humans, insect, value of investment. It decreases at a rate of 12% per year. The insect population on 1st Jan 2022 is 3.7 million. Calculate the number of complete years it will take for the insect population to first fall below 1 million insect. Now, first of all, let me go back and let me tell you the formulas. So first of all, we can be talking about an increase. We can be talking about a decrease. For increase, this is 1 plus R over 100. For decrease, it should be 1 minus R over 100. Got the idea? So now let's go back over here, and there it is. So therefore, first of all, let me write the formula. That is A equals to, this is P 1 minus R over 100 raised to power of n. What is A? That is 1 million. What is P? That is 3.7 million. This is 1 minus R. That is 12%. So 12 over 100 raised to power of n. And this time, n is unknown. So now when n is unknown, what will happen? Let's see. First thing first, since you see a million over here, you see a million over here. So even if I write those zeros of million, it would cancel out. That's why I did not bother writing it. That's the first thing. 1 divided by 3.7, when I divide, this comes out to be 0.270270 and so on. And on the right-hand side, 1 minus 12 over 100, that is 0.88 raised to power of n. This is 0.88 raised to power of n. Now the thing is, can this be solved by indices? We cannot solve by indices because such basis you cannot work it out with mentally. So therefore, the option that is left is logarithm. But logarithm, they are not part of O-level math syllabus. They are not taught in Igcse. So therefore, let me use the concept of trial and error. So how will we work it out? Let me plug in a value. Let me take n is equals to 5. So I'm grabbing the calculator. You can also do that and should do that. 0.88 raised to power of 5. This comes out to be 0.5277. So 0.88 raised to power of 5 is 0.5277. This is very less than that. Let me choose n is equals to 8, just a random number. 0.55 raised to power of 8. This comes out to be 0.00837. So 0.88, my bad, I just wrote the wrong value. 0.88 raised to power of 8. That comes out to be 0.35. 0.88 raised to power of 8 is 0.3596. So this is 3596. Still, it's not reaching this one. Let me choose another number. N is equals to 10. 0.88 raised to power of 10. Let me evaluate this. So 0.88 raised to power of 10, it's coming out to be 2785. 0.2785, it's very close to this. I think the next number will do the job for us. N is equals to 11. 0.88 raised to power of 11. So this is 0.88 raised to power of 11. It's below that value. That is 0.2450. They're asking for complete years. The thing would happen, it would fall below between the 10th and the 11th year. But since they're asking for complete years, so therefore I'll write 11 over here. That is how this question is done. So when n is unknown, we have to use the concept of trial and error. And now it says first fall. Why does it say first fall? Because once it has fallen, it will just be keep on going down. And let me just draw the graph. If the examiner were to ask us to draw this particular graph, so the graph will be that of decay. And let me choose a green color. It's going like this. And let me use a precision eraser to remove the part that is not valid for us. So this thing is not valid for us all the way over here. The population started from which value? This is P, this is T. It started from which value? It started from 3.7 million. So therefore, population in millions started from 3.7. It's keep on going down. That is the asymptote. And the asymptote is x is equals to 0, which is t is equals to 0. That is the horizontal asymptote. If they would ask us to draw this particular graph. So again, this was a specimen question. And look at the working, how they have done. They have shown it like this. And this is 0.270. And then n should be greater than 1. And then solve this. And they did not mention nothing more. So because it can be done by logs, but then you have to wait for P3, that is A-level second year, or you can use trial and error, and that is exactly what I've used over here. So this is for examination from 2025 onwards, 402402. It's a specimen paper. So now let's look another question. And it's about simple interest and compound interest. Again, this thing, pause the recording, try it out first. And once you have tried out, then play the recording to look at the solution. All good? So now let me just focus on this. I'm just focusing on compound interest. So now over here, what do we have? We have K invests $1,500 in saving account. So we are not doing the first part because in the first part, another person is also investing in a saving account. That is simple interest. The account pays compound interest at a rate of R% per year. At the end of 5 years, the value of the investment is this. Calculate the value of R. This is basic stuff. So therefore, we will write A as P1 plus R over 100 raised to power of N. A is how much? 1825. Value of investment, that is A. P is how much? 1500. 1 plus R over 100 raised to power of 5. Again, the same as before, 1825 over 1500, that is 1 plus R over 100 raised to power of 5. Therefore, let me write 1825 over 1500 raised to power of 1/5. It's 1 plus R over 100. 1825 divided by 1500 on the calculator raised to a power of 1/5. I'm writing this as 0.2. And this comes out to be 1 plus R over 100 comes out to be 0.04 and then many zeros. R over 100 is, this is 1 point. I think I just did one step in my head. And this comes out to be 0.04000. Therefore, R comes out to be 4.00. So R is 4.00. They're asking value of R. Percentage is already written, so you don't have to write a percent over here. So that is the value of R, that is 4.00. That is the working that they have shown over here. Just focus on this. So that is the working over here. Got it? So now these were O-level math questions. Now let me show you some questions from Igcse. Let's get started. So now I've already solved it. It's a walkthrough solution for the rest of the video. Q invests $3,000 at a rate of 4% per year compound interest. Calculate the value of her investment at the end of 6 years. That is the principle that goes over here. 1 plus R over 100. R is what? 4% per year. This is year. Just take care of that. So that's 4 over 100 power 6. This is 3,000 into this thing. And then this is the answer that you're getting. The first answer, usually they write, that is the one correct to 3 significant figures. The next question, there are 2 questions on this page actually. Now it says the value of a car is 8,000. Each year, the value of car decreases exponentially. So this is exponential decay. This one is exponential growth. Compound interest is growth. So now over here, calculate the value of this car after 5 years, 8,000, 1 minus 25 over 100 raised to power of 3, 8,000 into 0.75 cube. Let me evaluate it, 0.75 cube, and then multiplying with 8,000. And of course, the answer should be lesser than this. So this comes out to be 3,375. This answer is exact. I can leave it in this form. Next part, Amir invests $1,500 in an account. The account pays compound interest at a rate of R% per year. At the end of 8 years, the value of his investment is this thing. Find the value of R. PRNA. Just the same question as I have solved before. I think the third or the fourth question, just like this. Now, this is power 8. It becomes 1 over 8. And again, let me use the calculator. 1656.73 divided by 1,500. I think that's the favorite number. And raised to power of 1 over 8, that is 0.125. So therefore, raised to power of 0.125. This comes out to be this thing. And then, hold for a second. So let me write over here, 1.01250. Therefore, after the subtraction, so therefore minus 1 and then into 100, this comes out to be 1.25. So 1.25 is the answer. Let me double check. There it is. There it is. Both answers are given. Now, let's look at this. Anaya invest Anya, invest $6,000 in an account that pays compound interest at this percentage. At the end of 8 years, the account has earned 621 in interest. So just take care of that. This is interest only. Therefore, value of investment is how much? That should be 6,000 plus 621.70. So that is 6,000 plus 621.70, 6621.70. The rest of the working is just like the previous one. And again, you can get this answer. Let me get it. 6621.70 divided by 6,000. You get this value and then raised to power of 0.125. That comes out to be 1.0124. Subtract, that is 0.0124. And then there is a zero, there is a zero. Therefore, this is 1.240. If it's three significant figures, leave it like this. That is the answer. Value of R is 1.24. All good, all clear? And then this one, question 13. At the end of 2021, there were 27,000 rhinos living in the wild. The number of rhinos is expected to decrease exponentially. So this is decrease exponentially by 3% each year. So decrease, don't forget the negative side. Work out the number of rhinos expected to be living in the wild 4 years later at the end of 2025. So end of 2021, and then 2022, 23, 24, 25, that's 4 years. Give your answer correct to the nearest whole number. So this is the initial value. That is the value of R. That's the value of N. And let me work it out. So this is 0.97 raised to power of 4 into 27,000. This is coming out to be the value of A. A is coming out to be 23902.9. Now, they might have rounded it up. So some people rounded down also. So that's not a big issue. 903. So that is the rounded off value. All good, all clear. And I think this looks like the last question to me. The number of trees in a forest is decreasing exponentially. So now this is again decreasing exponentially at this rate. 11 years ago, there were 980 trees. That is the initial value, 11 years, percentage. Calculate the number of trees in the forest now. Give your answer correct to the nearest percentage. So again, 1.75 divided by 100. You get this value, subtract it from 1, and then raise it to a power of 11. And don't forget to multiply with 980. So therefore, this comes out to be A is 807.019. So 807, 808, 807. So this time they round down. So A is 807, rounded off to the nearest integer. And that's all, folks, for this thing, which is about exponential and exponential function, the word problems, whether it's about increase, whether it's about decrease. Pretty simple stuff. Just focus on the things, especially of the trial and error, which is in the beginning of the lecture. Take care, everyone.